Good afternoon, everybody, and welcome to our micro school. Can you hear us? If you can give us a thumbs up, please. Welcome to our micro school today. Get it out there, typesetting your work with LaTeX and Overleaf. And thank you very much to Gerhard Woithe that is going to be presenting this for us today. Maybe in the chat, if you can just tell us where you're from, your university. That's always interesting to see. But there, you are not here to listen to me, so I hand you over to Gerhard. And please feel free, type in the chat any questions. We'd like to go at the speed that you want us to do. Thank you. Have a wonderful micro school. Hello all.
Okay. Okay, I hope everyone can hear me. Yeah, welcome to this short introduction to typesetting your work with Overleaf. And yeah, as Renee mentioned, I'm Gerhard, and I would encourage you to please, at any point, if something is unclear or if you'd like to know more about something that I'm saying, please just put up your hand. Actually, better would probably just to be unmute and start talking, because I'm not going to be on Zoom. Yeah, so let's get started. So I hope you can see my screen. So I'm going to start with just showing you what Overleaf looks like. I mean, if you're starting from scratch, obviously you can just type in Overleaf in Google and the website will come up. You then create an account with your email address, and yeah, and then you can start editing. And this is what the interface looks like. So I mean, yeah, all so my sort of projects. Maybe I shouldn't be showing all of my projects like this, but so this is what I'm going to be dealing with today. Just a short demo on LaTeX. But how do we actually create such a document? Well, we click on New Project, and here you have options. I mean, you can either start a blank project and you call it what you want. Very uncreatively, you can call it project. And then Overleaf brings up the screen for you, and it has sort of a preset format of what your document is going to look like. And this gives actually a pretty good idea of what a LaTeX document looks like in general. So I think maybe this would be a good moment to just point out the structure of a LaTeX document, generally speaking. So you have this section, which is called the preamble, which is where you essentially define all of the parameters that you need that define your document. So you say, okay, I want to write an article as opposed to, for example, a book chapter. And then you say what packages you want to use. So I'm going to talk more about that just now. And then you have obviously the title of your document, and this gets added here on the document itself, and then your name and the date. And this section is the actual content of your document, and it's always enclosed by this begin document, end document sort of structure. And this is actually a thing that you will see quite often in LaTeX. So commands, if what I'm saying doesn't make sense right now, it will become clear just now. But commands are these things that basically make things happen in LaTeX, and they always start with this slash. I can never remember if it's called, I think it's a backslash. And you generally have sections of this form, where the beginning of the section is backslash begin and then backslash end. Yeah. So that's how you open Overleaf and create a new document. But let's go back to my actual demo that I put together for you. So yeah, as I pointed out just now, this is the preamble. In this case, the preamble is a little bit longer because I added a few things. This is the preamble, and here's the content, all the rest of the document, right? And this file is always saved in a .tex file, as you can see here. Yeah, so I should say something about the layout of the editor that you have here. So obviously you have here, you type in the commands and your content, and then as soon as you press Control, you press Control and then S at the same time, the document compiles and it actually displays for you here in real time, which is very, very nice. Obviously, yeah, you need an internet connection for this, which is, I guess, one of the major drawbacks of Overleaf. But there are other options available, and I mentioned those just now in terms of editors. But in any case, on the extreme left here, you have the so-called file tree, which shows you all your sections that you have, and I'll point out the correlations just now. But then here you have all the files that are actually relevant to your project. So this is the main.tex file, which is this thing. But then, I mean, you can also upload images and use them in your document, and that's what you do here as well. And I've done that here. And then also for referencing, which is something I'll get to just now, this is also another sort of file that you have here. This is always called a .bib file, by the way, for referencing. But that's all very advanced. It doesn't matter at the moment. So let me just quickly go through the preamble then. So here you set what type of document you want. As I said, okay, it's an article. This is your font or your text size. You can change other things about your document as well. For example, changing the size of the paper. I mean, there are lots of customizations you can do. And as always, for all of these things, I mean, Google is your best friend. That's essentially how I learned LaTeX, just by Googling stuff all the time. I mean, for coding, it is like that, always. Okay, and then here, packages. I'm not going to say anything about this now because I'm going to have a whole section on that just now, but this is a very useful thing. Also defining a custom command, I'll get to that just now. But note that all of these things go in the preamble, right? So this is before I even start typing the content that you see here. I'm just putting out things that I'm going to use later on. The title, the author, the date. Great, okay. And then I start my document. Now this is a pretty important command, this make title, because this actually takes all of this and puts it into the document. If you don't have this command, you're just going to start with an introduction with no title. Okay. Yes. I mean, you can also have a table of contents. This also goes just below the begin document command. Yeah, I suppose I can quickly show you that. So what I'm going to do now is I'm going to press Control S, right? And as you can see, the document is compiling right now, and it's reloaded. And now suddenly there's a table of contents. So what I did here, I didn't point that out, is I uncommented and commented it. So how you do that, I mean, you can obviously manually just type in a percentage sign, but there's a keyboard shortcut as well that I'll also mention just now for doing that quickly. So I'm going to take this out because it's a bit unnecessary to have a table of contents right now, and I'm going to recompile. Once again, it's compiling here, and then the document displays again. Cool. Okay. So the bread and butter of LaTeX basically is this sort of command. \section, whatever the name of your section is going to be. And this comes in a whole sort of hierarchical thing. So you have subsections and you have subsections. And I think they're on subsections, but there's another thing called a paragraph as well. And you can see here, for example, what a section displays as and then what a subsection displays as. And as I said, this is how you type it in, that part. And this is how you type in a subsection. And LaTeX takes care of the numbering automatically for you. And just to point out the way that I use it is I have the sections completely on the left, but then when I actually start typing content, I indent it a bit just to make this part of your text file actually more readable. So this is all the plain text. Obviously, this is just there's no fancy pictures and things in here. It's just keyboard that you're typing in things here. And all of the fancy stuff gets done by LaTeX in the background to create the document. Okay, so I have a lot of text here, but okay, well, I should probably have defined what LaTeX is. And I just wrote here, LaTeX is a widely used free software program for typesetting professional-looking scientific work. And yeah, it's free software. So I mean, that means in principle, you could go edit the source code and like customize it in any way that you want. But I mean, that there are other people who have done some very nice work for you to very easily do anything that you actually need to do. But it's so widely used that all the textbooks and lecture notes that you use in your courses most probably prepared with this software. And just out of interest, this is not what you see is what you get sort of software, whereas Word is. I mean, in Word, you type in and you know, okay, if I'm going to print that page, that's exactly what the page is going to look like. This typesetter this is what you type in, but then you first have to compile it, and LaTeX has to run in the background and create this document for you. So in that is the fundamental difference from something like Word. So yeah, content is entered as plain text, and commands, I should have actually had boldface this. Commands are used to specify structure and everything else, basically. And so yeah, it's a form of coding, essentially. But yeah, the advantage is, I mean, you don't have to fiddle around with the mouse to get images aligned. You know, in Word, there's always an issue with, oh, is this the same width? Is the text wrapping right? In LaTeX, I mean, that's all just taken care of by commands. So it's maybe a bit of a learning curve, but once you get it, it's really worth it. And okay, so I'm just gonna, here's some examples. So this is how you make your text bold. So here's once again the idea of a command. So you have a slash, and the command is called text_bf. And the text that you want to make bold is enclosed within these braces. And this is a very generic structure in LaTeX. This is how most commands function. I mean, sometimes you have commands that you take 2 arguments and then it looks something like that. But generally speaking, if you can understand that structure, / name of command braces, that's a very common thing in LaTeX. I mean, it's the same thing with section, for example, or subsection. Right, okay, so here's how you italicize it with this command, text IT, or underline it. Oh yeah, this is just a gimmicky little thing. So if you type / LaTeX like this, you see how it gets typeset here. That's just sort of a LaTeX own little form of branding. So okay, so now I say take careful note of the commands I use to make different types of sections. And I've pointed this out already. This is how you make a subsection and a subsection. So each time there's an indentation in on the numbers. So yeah, I mean, it's a diverse, you can use it for anything. Homework assignments, theses, okay, maybe not anything. I mean, there are some things that Word are still better for, but essentially anything that requires using strange symbols or a lot of strange symbols, LaTeX is ideal for that. I'm just going to stop and yeah, if anyone has any questions at this point or wants to ask anything, you're welcome to say something. Okay. Okay, so now let's get into it. So, oh yeah, this is things I actually already explained. So commands always start at the /. In general, I mean, these braces that look like this are special characters. So if you want to, the term is escape them, I mean, you have to start it with a /. So this is how you typeset braces if you actually want to include them in the text. Same thing with a percentage sign, because remember, percentage sign actually means comment. So you also need to escape it. Okay, I say some other things here. You can go, that's not so important. You can have a look at that later if you want. Oh yes, this is important. So oftentimes you have to write things with strange letters in them. For me, for example, I have to write Schrödinger quite a lot. Well, normally in Word, you would have to, I don't know, take your mouse and go to symbols or something, or if you're really good, you memorize the alt code for umlaut O. But in LaTeX, I mean, it's very intuitive. So once again, this command format is backslash, and then, yeah, whatever symbol you're looking for and the letter. So for example, this N that gets used in Spanish quite a lot as well is very intuitive needing it. So yeah, there's a command for you. So you don't need to memorize alt codes. And here I just have a little example of how you would use a footnote. So after you've typed in your text, you just say, once again, the same structure, backslash, command name, which is footnote, and then in closed braces, you have the text that you want in your footnote, which is this. And this is a nice thing. I mean, it's not very obvious now, but I mean, one of the packages I've used, it means you can click on the footnote and the document jumps to the footnote itself. So you'll see another example of that just now. Okay, yeah, this is maybe a bit pedantic, but so you always often have to type in things with quotation marks, right? But just have a look at the difference between these quotation marks, right? How it typesets over there, and these quotation marks, how it's typeset over here. So here you see this quotation mark. I mean, it's inverted as opposed to this one, and I mean it just looks weird. And this is how you enter quotation marks in LaTeX generally for it to be typeset correctly. That's just I guess that's very niche, but it's it's just a little attention to detail that I think is pretty cool. But more important things are, for example, text sizes. So once again, command, same format. So you can have tiny text, or you can have huge text, or you can even have bigger text than that. I can't remember what the commands are, but I mean, as always, as I mentioned, Google is your friend. Just type in something like LaTeX text sizes or something like that. But then when you've changed the text size, like, be careful to put it back to normal size at the end. Otherwise, I mean, everything's gonna... Okay, let me just quickly show you what happens if you don't do that. So I've deleted normal size now, and I'm recompiling the document. And now the whole document is huge. And I mean, that you obviously don't want that. So I'm going to put back normal size, recompile the document, and now it's okay again. Okay. Okay, starting a new line. In Word, you just press Enter. Here, you need to actually type //. So this command means break the line. And so there you see the line gets broken and text starts on the next line again. Okay, so maybe this is also a bit niche, but you can add filler text. I'll get back to that just now. The important part is changing text color. And here is an example of a command with two arguments. So here you see once again the structure. /, name of the command, which is text color. But in the first argument, you say, okay, what color do I want to be the text? And I said, okay, I want it to be red. In the second argument, you actually type in your text. So there you see. So first argument, which is the color, text, right? Okay, and this also just demonstrates how you start a new paragraph. So you press enter twice. So whereas this command just skips one line and it looks like this, if you press enter twice, you start a new paragraph. And a new paragraph obviously is indented. So you can see from here to here, a new paragraph has been started because I pressed enter twice here. Okay. Starting a new page, I mean, that's a pretty obvious command, just / new page. Now we jump to a new page. Cool. Now this is how environments work. So this is also of that, well, it's not of the same structure, but remember I pointed out how you begin and end the document. So it's \begin, \end. That structure is generally used by so-called environments on LaTeX. And this is an example of an environment. So you say \begin, and then you say, what is the name of the environment? The name of the environment is itemize. And then at the very end, you have to say end itemize in this way. But what the environment itemize does is it makes bullet lists basically. And every time you type in \item, you make a bullet. And then when you start typing, well, that's the text that goes next to the bullet. And exactly the same concept. If you don't want bullets, but you want numbers, well, you just change the name itemize to enumerate. Yeah. And then, okay, this is just a final example of like the lowest down you can go in the hierarchy of sections. It's called a paragraph. And that's how you enter it. Okay, so now this is an important part, how you enter maths. So obviously, I mean, I suppose we're all sort of in STEM, more or less, and you always use Greek letters. And literally that just involves typing in the name of the Greek letters preceded by the old backslash, of course. So you have \alpha, you have \xc, you have \psi. And LaTeX just, typesets it like that, and no problems. I mean, imagine having to typeset that in Word. I mean, you'd have to hunt through a menu or something like that. Yeah. So that's how easy it is in LaTeX. But okay, sorry, I just need to say, okay, you can also use Hebrew letters like Aleph. I mean, there's a lot of wacky things you can do. But the point is, these symbols, because they are read as maths, they are enclosed by $signs in like this. So I pointed it out here, $sign, whatever your maths is, another $sign. That's how you enter maths inline. So inline means you don't make a break for a new equation, for example. You just, while you're talking about it, you're saying, oh, here's some maths, and then you continue your sentence. And okay, also just an important point. I mean, you always end up using Roman letters as well for names of variables, like a squared plus b squared equal to c squared. Pythagoras, for example, where it's a different sides of the triangle. But the a and b and c are symbols in this case. They're not just normal letters, so they need to be enclosed in the math environment because they are mathematical symbols. So you can see here the difference between, for example, just typing it here, just straight up, versus enclosing it in a math environment. Yeah. And I mean, it essentially italicizes it. It gives it a special font to signify that these are math symbols and not just text. So yeah, in the same sort of idea, trig functions, you can't just type in a math environment sign like this, because then LaTeX thinks, oh, it's s times I times n times x. You need sign has its own command like that, and you can see the difference between the two styles of typing it in here. So here you can clearly see, oh, this is some function of x. Same thing with lin. Yeah, so any function used in a mathematical context, even things like trace, they are functions, not symbols, and so they need to be preceded by a backslash. But obviously, we want to display our equations. That's how math is normally done. So once again, you use environments. So once again, it's a structure \begin. What environment? An equation. And then at the very end, you say \end equation. And actually, it's very nice because late or Overleaf actually auto completes it for you. So let me just begin typing here. I want to enter an equation, so I type begin equation, and it's auto completed it for me, and then I can just start typing my equation. So yeah, I mean, Overleaf is very cute in those sorts of ways. Yeah, okay. So I do see entering math is intuitive, but I mean, there are obviously some commands you need to know, and this is once again a matter of Googling. So I'm just pointing out some basic ones like fraction, which is a 2-argument command. You can see how it translates here. And then the exponentiation operator. I mean, it's also pretty intuitive. So I type in the equation here, and it displays here like this. Okay. Okay, this is, I guess this is maybe a little bit niche, but you can see there are different options also for entering or for what your symbols look like. For example, if you're working with vectors, if you want them italicized, you can use this command. If you don't want them italicized, you can just remove the star, or you can use this vec command, which just looks like this. And I wouldn't recommend that. Yeah. Something I should point out is how you label equations. So once you say begin equation, you can type right next to it label, and then you say, okay, it's an equation. What is the name of the equation? I call this one not nice. And then later on in the text, you can reference the equations, and that's how you do it. You type in the command \ref, enclose in braces, name of the equation which you typed in there, and then when you're actually on the PDF, you can click on it, and it takes you to the equation. So okay, so here is how you use this is another type of environment, the align environment. If you want to have things underneath each other. So here you have, once again, starting a new line operator. And these ampersands set the alignment. So you can see, okay, I use the ampersand there and the ampersand there in front of all of the equal signs. So that aligns the equal signs underneath each other. Okay. Yeah. So obviously, yeah, I think we can make this document available. So you can have a look at this later again at all the details and copy and paste for your own examples. So here's an example of using matrices. This is just another environment, and you can have a look at that later. But yeah, this is an example of like, you can really do some nasty looking stuff on LaTeX, and this is what this command translates to this, right? But the interesting thing is actually, oh, it's not throwing an error right now. Let's recompile. Oh, there we go. Okay, so you see here the math is sort of sticking out over the margin here. And here LaTeX tells you, oh, it's an overfull horizontal box. So that just tells you, maybe just try to reformat your math, maybe like move things a bit down. Otherwise, I mean, your document just looks a bit strange, things sticking out in the margin. Okay, and let me quickly move on to figures then. So the first thing, obviously, if you need a figure, you need to upload it. And you do this with this button over here. You just click upload, and then you can select a file from your computer. You have some sort of, you have your documents here, and you can choose any of these, whatever figure you want to upload. And once again, it's an environment. So it's begin figure, end figure. In the middle, the actual figure that you want to include. And this is just included with include graphics and whatever the name of the image is. And the name of the image you will obviously just find here after you've uploaded it. This square brace, so this is something that some commands can take. It's called an optional argument, and that just specifies, in this case, for example, how big you want the image to be. And you can give it a caption. There we go. I should also just point out this H option. So that's something to Google as well, but there's like different options you can put behind this begin figure command. Oh, geez, sorry. But these commands basically control where your figure actually gets displayed. So, for example, if you have the small h, your figure might be more loosely sort of distributed. So maybe LaTeX makes a decision, oh, okay, it would be better to put it on the previous page rather. Yeah, but the big H forces it to put it right there in the file where I said I want it, and I prefer that option. Okay, so this is maybe a bit of an advanced example, but it's pretty intuitive if you just have a look at what the syntax is like. And yeah, obviously I have the election results here tabulated in the different provinces. And once again, it's an environment. It's a table environment. So you begin the table and you end the table. And this is a bit different because you have an environment within an environment here. So the environment is tabular. And these commands control the alignment of the text. So the first column here, I say, okay, is aligned left. And the second column is aligned right. And this little thing in the middle just says, oh, I want them separated. I mean, yeah, that just controls the number of columns, basically. And then you input things basically, yeah, left to right. So I say, okay, the province, and then the ampersand goes from one column to the next. So to the province, okay, and in the next column, I want the ANC vote share, okay. And then here I say, okay, let's move on down to the next row with the / command, because remember that starts a new line. And then same format. First column, I want KwaZulu-Natal, and the second column, I want this percentage. And you can obviously also caption it. Okay, this is a bit niche, but yeah, there's a different package available called book tabs that just makes your tables look a bit nicer. But the syntax is exactly the same. Okay, now this is a pretty important part. So packages. Yeah, so this is specifically useful for domain-specific symbols. And I use, obviously, the example of the physics package. So it just essentially saves you a bit of typing because packages define commands that are, for example, often used in your specific domain. So once again, just the best is just going through an example. So here you have this equation, which is this, and you have this equation, which is this equation. And they look exactly the same, right? You can't see any difference between them. But look at how different the commands are, right? I think I'm not going to go in detail through all of the commands, but just the one example I can point out maybe is, look at the syntax for entering a commutator, which is this square bracket thing, right? So the physics package has a special command called \com that takes two commands that allows for typesetting a commutator easily. Whereas here I have to physically go type in, oh, square bracket, oh, where does the other square bracket go again? Where does the other square bracket? So commutator, that's just one example of how physics package makes your life easier. And I was talking about packages earlier, so this is what goes in the preamble here. So once again, you just say the command use package. Okay, what package do you want to use? Okay, also obviously I want to include graphics, so that was for this thing I had just now. I need this for including this, and then this is a very nice thing also to use, the AMS packages. Yeah, if you're going to type math, you definitely need to use all of these packages. And this is the physics package that I was talking about just now. So, yeah. And to see, is a package going to be useful for you, just look at the documentation. I mean, I actually have an example here of what documentation looks like. Yeah, here's the documentation for the physics package. And it just explains exactly to you how all the commands work. And yeah, there are examples, very easy to use. Okay, so this is also a nice thing. You can define your own commands. So all of the commands I've used so far are sort of predefined by LaTeX. But you can also just define your own command with this. It's a command saying new command. And this is the format. So you say, okay, new command. What do I want to call this new command? I want to call it Einstein. And in the second argument, I say, okay, when I type \Einstein, what must happen? I wanted to typeset the Einstein field equations. Because imagine having to type this out every time you want to reference the Einstein field equation. So all you need to do is just define the command Einstein, and you just type Einstein, and this thing gets typeset. And that's something you do at the very beginning in the preamble still. Yeah, so I hope you can see how that might be useful. Oh yeah, just to check your memory. Do you remember equation 4? So let me just click on it, and it jumps back to it. I mean, yeah, that's just a demonstration of how useful it is to label and reference your equations. So once again, this is how you reference your equations. Okay, cool. Just a bit of advertising for Overleaf, I guess. So, so Overleaf, there's no installation. You can just basically start using it. It's very good for collaboration. So you can work simultaneously with people. I mean, this auto suggestion thing that I pointed out, where you just type in, oh, they even did something, but I just say begin equation. Oh, okay, well, if you can actually type equation, and then it just auto completes it for you. I mean, there are many other examples. Once you start using it, you'll see it's just so fast. Okay, compilation and document preview is easy. It's just Control S. And this is, wait, I didn't point this out. Templates. So this is a very nice thing about LaTeX, or about Overleaf, sorry. So if you say new project, here you have all the templates. So you just go to view all, and then whatever you want. I mean, okay, there's books, there's letters, there's CVs. So yeah, just go to newsletters, for example, and you can click on any of these. Oh, what a coincidence. And you say open as template. And yeah, I mean, all of the plain text is already here. And this is what the document sort of looks like. And you can just start tweaking and making it relevant for your own application. Okay, so as I said, yeah, it needs an interconnection, which is not great. So there are other editors like Text Studio. I used to use Text Studio quite a lot. Yeah, VS Code with some extensions. If you saw Dean's Micro-school on the 19th, he talked about how VS Code works. So have a look at that. TechWorks is another one. Yeah, there's a lot of options, but if you're gonna go for an easy use one, Text Studio is pretty good. Yeah, Overleaf has a lot of documentation. Oh yeah, and yeah, you can have a look at this intro from LaTeX. By the way, this is how you enter URLs. Once again, command, braces, and the URL, and then it typesets like this, and it's also clickable, so you can just click on it, and the PDF takes you to a website. So it's pretty cool. Yeah, some keyboard shortcuts that you can have a look at. Yeah, how much time do I have left?
I think we can finish up. You can just end off. I'm not gonna. You can just say, okay, let me thank you.
Okay.
I think we're done.
Yeah. So sorry, there are some advanced things I put in here which I didn't really want to get into. But once you have a look at this program or at this document, you can have a look at it. So you can, for example, draw pictures on LaTeX. You can do referencing, and here's a bib file as well where you can have a look at an example of that. You can even make presentations with it. And yeah, so let me just quickly end off then. So if you're done with your document, you can download it easily. So you can just say, click that button to download the PDF. Instantaneously downloads, opens as a PDF. And yeah, have a look at this file tree. So this gives the large level overview of your document. And Google is great. ChatGPT is also okay. If you are not too naive. Yeah, take everything it tells you with a sizable grain of salt. And the key point is anything you need on LaTeX, there's probably a package for it, and you can just Google it. Yeah. And so with that, I'm going to end off. And if you have any questions, once again, you're welcome to put up your hand. Let me just have a look at the chat. Yeah. Cool. Thank you. Yeah.
I would like to thank Gerhard very much for this excellent talk. And if you please let us know what other things you would like us to teach, or if you would like us to continue with this, maybe more advanced. So please just let us know, give us feedback. And thank you very much for being here today to everybody. And you will also definitely find this by tomorrow on our YouTube channel. Thank you very much for being here. Take care. All the best. We'll see you again. Bye-bye.